So today we are going to talk about mixtures. So our main objective in this lesson is to first understand the separation of mixtures and their purification as well. Now before we continue, we are going to pause the whole lecture first, and then we are going to introduce two concepts which are elements and compounds because they are important in this lesson. They are what constitutes a mixture. Now let's understand what elements are. So they are any substance that cannot be broken down into simpler bits by either physical or chemical process. So why they can't be broken down into simpler bits is because they contain only one kind of atom. And remember in our chemistry previous lessons during conservation of matter, where we stated that an atom cannot be created nor destroyed. So this makes us understand that elements can't be destroyed because they contain only one kind of atom which can't be destroyed. In contrast to elements, we have a compound, which are pure substances that are made up of two or more elements that are chemically bonded. So which this tells us that compounds can be broken down due to the fact that they contain two or more kinds of atom. So these atom kinds can be separated. Now this leads us back to our topic, which is mixtures, because mixtures are made up of either elements or compound. So take note of that. Now a mixture is a material made up of two or more agents that are physically mixed but not chemically combined. So a mixture can be a it can be made up of either an element, maybe two or more elements, or an element plus a compound. So note that mixtures are only physically combined, which implies that there is no chemical reaction which occur during their combination. This shows that new bonds are not formed and new substances are not formed as well. So the constituents still retain their chemical identities, which makes it easy for them to be easily separated. Now we are going to introduce a mixture. It is known as simple sugar. It's a simple sugar known as sucrose. So this mixture contains of elements such as carbon, hydrogen, and oxygen. So it is a mixture, so it is separatable by means such as evaporation and distillation. So here are some examples of mixtures. Though these mixtures only contain some elements, but there are other mixtures that contains both maybe compounds and elements. So that's it. So we are going to talk about separation of mixtures. As we already explained, mixtures can be physically separated because they contain different types and kinds of atoms. So we are going to talk about the different separation techniques. So the first on the list is filtration. And filtration is a separation technique used to separate heterogeneous mixtures, especially mixtures that contains either a solid or a liquid. Instance of this can be seen in the separation of chalk from water. Meanwhile, there are other techniques of filtration such as separation of solid from solid. An instance is the separation of stone from chalk powder. And then there is solid versus gas separation, which an instance can be given from the separation of dust from air. Now let's go to the next separation technique, which is the crystallization. So crystallization is a method used to separate soluble solid from a liquid. So that seems like a very simple definition. And if we cross check, you can see that it seems like it's a bit similar to filtration, but no, it's not. Because in this separation, like in the separation technique, the solution containing the liquid is firstly evaporated, then cooled to allow desired solid crystals out. So the goal in crystallization is to separate only the soluble solid capable of crystallization. So that is the major difference between crystallization and filtration. Because in filtration, we can separate any type of solid, but here we can only we are only capable of separating solids that are capable of crystallizing. And examples of such solids are sodium chloride, sugar, and potassium chloride. So in examination conditions, when you are provided with any of these type of solids, and then we have a mixture with a liquid, the preferential method of separation should be through crystallization in opposing to filtration. So distillation involves boiling of the solution, then condensing the vapor into a liquid through cooling. So distillation is used to separate liquid from the mixture. But in contrast to filtration, the liquid portion of the mixture is the most important constituent here. That is the most important part of what you are looking for. Meanwhile, in filtration, the solid portion is the most important part. So that is it. Then examples of um, distillation processes seen in the separation of alcoholic liquor from fermented materials, or the separation of two or more liquids with different boiling points. For example, the separation of kerosene or gasoline from crude oil. So the next separation technique we have here is called chromatography, which is a separation technique used for the separation of mixtures into its components. So the mixture is first dissolved in a fluid solvent. This solvent is called the mobile phase. So this solvent can be either a liquid or a gas. So it carries this mixture through a system. So this system separates the different components of the mixture. So it is mostly used for separation of mixtures such as dyes and inks, which cannot be separated through conventional separation techniques like filtration and the rest of them.